Are we really going to try and do this from a photo? You know, a pre-series photo, this is not going to tell you anything. All right. Welcome back to Monroe Live. So there was a leaked photo of the Tesla CyberTruck interior. And there were some people who were making some comments about what they see. We thought that we would give some of our opinions. However, this is a pre-series build. Because of that, don't trust anything that you see. Being a pre-series build, most likely the tools that are needed to create this interior have not even been finished yet. Because of that, this is truly a prototype. And there are many different ways of doing a prototype. In my past life, if I wanted to get something that was as accurate as possible and even function properly, we even had IPs that were machined out of a solid block of ABS. Machined to where it takes the shape of the entire IP, but it's only 2.5 millimeters thick. But we would have to cut it out of a giant block. 3D printing makes it a lot easier now, so you don't have to machine out of complete blocks, but still, there are a lot of things in here that are going to be pre-street, that are going to be prototype, that will not really match what the vehicle will finally be. But let's talk about what we see. Now, the first thing that people are going to notice is the steering wheel. You can put any steering wheel on a vehicle as long as it's within the same vehicle family. So this might be switched out for something else. We don't really know. However, due to its shape, we can assume a few things. It almost has the profile of the yoke, but of course it does not. We have a solid cross section up top. That was very emotional for some people, the idea of the yoke or using the yoke. And it would be a completely different learning experience to be able to use a yoke in everyday driving. Some people, because of their industry and because of their vehicles, already do. But for many others who have spent many years using a traditional steering wheel, that was too much to ask at one time. We understand that. But let's make a few comparisons. Let's grab the yoke. First, we have the overall shape, but we do have a connection at the top. But look what we don't have, a connection at the bottom. That would technically allow you to have more area to grab with your hand. Whereas this center completely fills down and closes out the bottom. But even looking at that general shape, it has the same overall theme, but missing that lower connection. If we went from the steering yoke and try to go forward in vehicle, we have a couple of different materials that we're seeing. Now, you see that large expanse going up to the windshield edge. Because of that rake of the windshield, lots of times people would complain about glare off of the material on top. This looks to be like an artificial suede material. So it may be a vinyl up to this line, suede going forward. That, of course, would be for that glare. But look at this seam. That looks like a decorative stitch joining between the two. All right, for that, let's go ahead and look at the Model Y and the Model S top pad. Here's the Model Y top pad. This is a traditional build for a lot of high volume vehicles. There's a plastic carrier panel. There's the A-surface vinyl PVC material. But there is a foam layer, which you can see from the cutout line here. So we have a skin tool, we have a plastic tool, and then we have a foam tool that's going to fill up this gap. This is nice because you can get a lot of very complex shapes. Just look at these corners, nice tight corners wrapped all the way around the edge. You cannot do that if this was a hand wrapped material. However, because of this construction, every tool required for this construction is very expensive, and this is very heavy. But we see a live stitch. Let's look at the Model S. There is a live stitch here. So if we consider this, we could say, okay, there's the vinyl edge up to the stitch that we see on the CyberTruck, but then it is suede going forward to the window edge. All right, well, what's unique about this? This is incredibly thin, incredibly light, but this has a lot more manual operations. For a lower volume vehicle, much like the Model S, we are saving weight, we are saving the tooling cost because I'm only paying for the injection mold tool and a press tool. which is great for low volume because you don't really know if you're going to make enough to make up for the cost of the tooling. High volume can take that tooling. Low volume cannot. We don't know where the CyberTruck is destined to be in total volume, but if they're able to eliminate one of these very expensive tools, either the skin tool or the foam tool, this would be much lower cost and much lower weight. So in talking about that IP going from basically the line that's presented right to the occupant all the way to that windshield edge, what do we think is underneath that? All right, when most OEMs are starting up a new vehicle, especially startup companies, the first structure that they're going to put into their instrument panel is going to be a welded steel structure or possibly welded aluminum. And Tesla in their beginning used something like this. In doing that, you have flexibility, but every one of those welds, every one of those stamped components is another tool that you need. If I'm building low volume, this would be more cost effective. But once I get up to a higher volume, this gets to be very expensive. You're stuck with that same cost over and over. And the more you make, you're just spending more and more money. So they graduated past something like this and went to what's on the Model Y. This is a formed aluminum tube structure, and all of these cross braces are an injection mold. So this tube is put into an injection molding machine, and all of this structure is able to be made in one shot. That saves a lot of time, that saves a lot of labor, and that saves a lot of tooling. Rather than having to have a separate tool for every one of those stamped components, I have a hydroforming tool for the aluminum, and I have an injection molding tool. The problem gets to be, how big is that injection molding tool? You see this large section here. This center support goes from that IP all the way to that windshield edge. The farther away I get, the larger this base structure needs to be. That would be a big problem on the CyberTruck if they took this design going forward. But let's look at the Model S. Here is that structural crosscar beam for the Model S. Rather than have a stamped aluminum structure, they have this C-channel steel structure. They still have the overmold providing all of those legs and arms. The overmold actually flows through the steel structure, locking it together. But what are we missing? That large piece going to the windshield edge. This is a much smaller tool profile. They decided that it actually made more sense to go back to a single stamping for that windshield edge connection. If you think about it, this stamped aluminum is basically of uniform thickness throughout its entire profile, going from that IP crosscar beam all the way to the windshield edge. If I had to mount this large injection molded piece, it would be so big at the base, it would waste a lot of raw material. Now, why is it important not to waste a lot of raw material with this material on the Model S? Because this is unique. This is injection molded carbon fiber. Now, when we first saw this looking at the Model S, we were trying to figure out why. Why did they take the leap to try and integrate injection molded carbon fiber? The Model S was a low volume program, but a very, very high selling point. So you could absorb some of the costs of going to a more expensive material. In my mind, I felt that Tesla was trying to stretch their legs. They were trying to see what they could do. Yes, they're going to pay more money for it now, but they're going to see what's going to be possible going into the future. Maybe the determination to test out an injection moldable carbon fiber on the Model S was thinking about the CyberTruck. Because think about it, I have my crosscar beam, which is basically going from the A-pillar to A-pillar, supporting all this A-surface. But I need to reach all the way to this windshield edge. Most likely, they're going to use some sort of a stamped structure, just like we did on the Model S, or they did on the Model S, to give them their connection below the windshield. But if this needs to be a structural beam in a vehicle like the CyberTruck, maybe that explains why they went to test carbon fiber. Now, it's not just the instrument panel that we're seeing here or the steering wheel. We're also seeing a portion of this center console. All right, well, there's not much that we can determine from the center console. We can see it does not connect all the way to the eyepiece, so it has a crossover through there. But what do we know about the Model S center console? This is the structure that we found within the Model S center console. Now, this is basically just the bin. This is the structure itself. You'll see that this structure does go far forward in vehicle. This one does not. This also was a stretch to their legs program. If you really look, I don't know if it'll show up on camera, you see the color difference between these two pieces? It's because they are not the same material. This is also injection molded carbon fiber. So I was questioning that too. Why do they need something so structural for a center console? Now, I've seen some center consoles that have a large molded structure like this. I've seen some that use stamped steel for a structure. I've seen some that had giant castings, but I've also seen some that had no structure whatsoever. They just have an A-surface skin that bolts to a mount, and they're completely hollow within them. The vehicle's use case, or the vehicle's design, dictates whether or not you need some sort of a structural element for the center console. I don't know what the crash environment for the CyberTruck would be, so I cannot tell you what the structure supporting this center console would be. But because they were stretching their legs with this injection moldable carbon fiber, I have to assume that some of the lessons learned from here would move forward. Okay, a traditional armrest. Not as traditional of a storage bin door. This is a timber top. I don't really like those. To me, it almost seems like having a mechanism just to have a mechanism. The nice thing about them is they normally store in a very low profile. But to me, it's a lot of headache for what it is. But that's just my personal opinion. But going back to the idea about this being a prototype build, this being a pre-street build, we can see that really if we look at the seat. Look at the condition that we see here. Again, I don't know how well this shows up on camera, but you see the looseness in the sewn cover here? Most likely that was a one-off cover. And also the foam is not completely filled out for its shape. So you can actually hand cut and skive these foams if you're making prototype. I would purchase them in blocks, and literally you would use a small air sander and just shave them down to get to the shape that you want. It's nothing you would want to do for production, but when you want to try and simulate the correct foam density for your vehicle, just so that someone can sit on it, you can do that. And this looseness in the cover here tells me this was a hand built. This is not off of production tools. But the side shield tells me that same thing. All right, very, very boxy, but it's not just that it's boxy. Look here. You see this shadow line? It almost seems like the material is folded on that edge. If it's folded, most likely this is a flat sheet stock material that may have been thermoformed to this shape, which is why it has very, very 90-degree corners, because it's hard to make a very rounded shape if you're trying to build it by hand without actual tooling. This truly may be a hand-built prototype on that side shield. I'm not sure. I'm just basing that off of the seam line that I see here and the fact that these are very sharp corners and edges. In the end, it's exciting to see anything about the CyberTruck. Any news or any advancement getting it farther down the line, any possible customer wants to see that. They want to get excited about it. Personally, I don't think that we should put too much stock in anything that is most likely a pre-series build, most likely a hand-built. Your design most likely will not look like this. It will come from actual production tools. But there are a few elements that they may bring forward, and it's exciting to see those elements. So that is all for today. Thank you very much for watching Monroe Live. Please subscribe so that you can see future videos. And I have asked Corey, definitely we are getting a CyberTruck, and we will be tearing it down every nut and bolt. When that happens, can't tell you. Have a good day.